The idea that we'd like to explore now is an idea called a reference angle. Now, a reference angle occurs when we have an angle that's swept out from the x-axis or from standard position into a non-acute position. So in this first one, notice that the angle is swept out to quadrant 2. Well, its reference angle is going to be the acute angle that remains that as it gets swept out to the closest x-axis point. So I have my initial angle, and over here theta prime is my reference angle because it's the acute angle to the x-axis. In my second example, I have a theta that's swept all the way out into the third quadrant. My reference angle then would be the distance from my angle back up to the x-axis. And notice again, that's an acute angle. Then likewise, or similarly, in my last example, I have an angle swept out into the fourth quadrant. You see it sweeps out all the way over past 270 degrees and less than 360 degrees. Its reference angle then is we're looking for an angle that's less than 90 degrees. And we measure that by looking at its angle and the angle measured to the closest x-axis point. So notice that all of our reference angles are going to be less than 90 degrees. So let's look at an example of how we can take an angle and determine its reference angle. If I have an angle that's swept out 345 degrees, I know that it's past or it's in the fourth quadrant because it's greater than 270 degrees, which is right along the y-axis, and it's less than 360 degrees, which puts us back to game zero or ground zero. So my angle, my theta, swept out 345 degrees. What I'm looking for now is what I want to discover is what is this angle right there? What is its reference angle? Reference angle in this particular case is I know if it went all the way past and all the way back in, that would be a full 360 degrees. I want to subtract from that the sweep, which was 345 degrees. So my reference angle, my theta prime, would be 15 degrees. So angle is 345 degrees. Theta prime is 15 degrees. Theta equals 5/6 pi. What is its reference angle? Again, its reference angle would be the acute angle formed as it connects to the closest x-axis. So this is what we're looking for right there. We notice that this value or this angle, initial angle, is between pi and pi halves. So we know that a full sweep to the next one would be a full pi. And I would like to subtract from that the 5/6 pi. And doing that, it's going to give me this remainder part in there. How do we do that? Well, a full pi is also a full 6 pi. Take away a 5/6 pi. The reason why I did that, I wanted to have a common denominator. And when I have a common denominator, then I'm able to add or subtract fractions or rational expressions. So I'm left with then a 1/6 pi. Or maybe cleaner, leave it as pi 6. So pi 6 then would represent my reference angle if my initial angle was 5/6 pi. When we're looking at a theta equals a negative 135 degrees, our reference angle follows similarly to what we've done already. However, we want to make sure that if you want to draw a picture like I did, that we sweep the angle out in the correct position. Remember, a negative means we start going clockwise from the standard position to get to the sweep of that angle. So I swept it out a negative 135 degrees. So what's my reference angle? My reference angle is the remaining bit to get me back to the x-axis. So what is that remaining amount? Well, if I remember that the entire arc is 180 degrees total, and I've already used up 135 of those degrees, what's left? I have another 45 degrees that's left. So my reference angle then would be 45 degrees. Now notice that I have a positive because our reference angles are going to be positive angles. So I'm just interested on what the magnitude of that sweep is. Not that it's going to have to move into the negative direction, but just what the magnitude is. So its reference angle is 45 degrees. Even though 45 plus 135 don't add up to 180, We're using this idea just to help us to understand what its absolute value or its magnitude is. Our last one, we want to look at a sweep of 2.5. Well, that's in radians because it's not designated with degrees, but where is 2.5 radian at? Well, if we remember that a full pi radian approximates to 3.14, and then half a pi would be half of 3.14 is roughly what? 1.57. So 2.5 then would have a sweep somewhere between those two. So I know then that the sweep is into the second quadrant. So how do we find then based on that? Its reference angle? Well, if I know the full distance that we need to go to get to the x-axis is pi, and I'm going to subtract from that 2.5, what's that going to equal? Well, again, because pi is not designated in 2.5, it's in radians, so let's use the approximation of pi, which is 3.14 minus the 2.5, and that leaves me with 0.64 looks like. So then the reference angle would be 0.64 approximately. Now let's try to find the reference angle of 580 degrees. Wow, that's larger than one revolution around. So where's 580 degrees at? Well, one way we can figure that out is determine what its coterminal angle is that's less than 360 degrees. So if we have a degree at 580, its coterminal angle then would be one revolution less than that, which would be 360 degrees. And I'll be left with 220 degrees looks like would be its coterminal angle. So given that, I can find its coterminal angle then is going to be between 180 and 270. So there's my coterminal angle, and the coterminal measurement is 220 degrees. And then from there, if I want to find out what its reference angle of 580 degrees, all I'm looking for is the distance to sweep back to the nearest x-axis, which is that's my prime. And so what's this distance that I have already over here? If that's a full 220, if it's 180 to right here, and then I have to go another 40 degrees to cover this spot, so this would be 40 degrees. So my reference angle would be 40 degrees. We have an angle, or initial angle of 8/3 pi. Again, that's greater than one full revolution. It's greater than 2 pi around. So we probably should find its coterminal angle to help us have an idea of where it would lie in and what quadrant and so forth. And so I imagine that we could probably take away a full 2 pi from that. So let's go 8/3 pi, take away 2 pi. To do that, let's get a common denominator. That's 8/3 pi, take away what, 6/3 pi? Is that 2/3 pi? Or is that 2 pi? It is. My result is 2/3 pi. So I have an angle that's 8/3 pi. It is a coterminal angle that's at 2/3 pi, one that I'm able to identify a little bit better. And I'm able to identify it in roughly right around there somewhere. So I have some measurement of the coterminal angle now. 8/3 pi, but it's also the same thing as 2/3 pi. So what I'm looking for, its reference angle, is the sweep, or the amount of sweep to continue to get to the x-axis. So that's my prime that I'm looking for. 2/3 to the angle. How many more to go to complete pi? It would be 1/3 pi. 2/3 pi plus 1/3 pi makes a full sweep, and that's what I'm looking for, is what's the remainder to make this reference angle sweep all the way back down to the x-axis, 1/3 pi. we have negative 13.6 pi. To find its coterminal angle, we're going to have to add some multiple of 2 pi's to get back to a degree less than 1 full revolution. How many do we need to do? Is it just one 2 pi around, or is it multiple 2 pi's around? One way that people like to do that is they just want to look at this number as a mixed fraction. And what is that? That's the same thing as negative 2/1/6. So this 2 tells me then that if I added, or if I added a positive 2 pi to it, I'm still at a negative result. I remove the negative 2, but I still have the negative 1/6. So what I need to do now is I need to add 2 revolutions to it. So I have a negative 13.6, and I'm going to have to add a 4 pi. Because 2 pi won't be enough to add to this to get a positive coterminal angle. So I have to add one more revolution, which is why I have another multiple of 2 pi, a total of 4 pi. Now let's add these together. So I have negative 13 pi, 6, common denominators makes out what, a 24/6? And I'm left with 11/6 pi. So my coterminal angle then is 11/6 pi, which puts me right about there. And 11/6 is the angle all the way around from standard position. So that is my theta, which equals 11/6 pi. I got 2 pi's there. Let's try to make that 11 as best as we can. So 11/6 pi is my measurement all the way around. How do we determine what its reference angle is? Reference angle is what's the remaining sweep to get it back to the closest x-axis. That value right there. Well, if I know all the way around is 2 pi, and I want to subtract the initial sweep, which was 11/6 pi, what do we result? Well, 2 pi is the same thing as 12/6 pi. Take away 11/6 pi, and I'm left with 1/6 pi. So my reference angle, this measurement right here, the absolute value of that measurement is 1/6 pi. And so 1/6 pi, or pi over 6, would then become my reference angle for my initial angle of negative 13/6 pi. Again, I want you to understand why it's not negative. We're just looking out for the angle back to the x-axis and what the magnitude of that sweep is. So it will be a positive value when we're looking at their reference angles.